So the first example here we have calcium, so Ca plus oxygen, O2, producing or yielding calcium oxide. So to show the conservation of mass, what we want to do is we want to have equal numbers of each of these elements on both sides. So what I like to do is I like to keep a tally of each element involved. So we're going to look at calcium and we're going to look at oxygen. On the left side, my reactant side, I have only one calcium, but I have two oxygens. On my product side, I only have one calcium and one oxygen. So how can I balance these two sides of my equation? So if I'm looking at calcium and I'm looking at oxygen, if I have two oxygens, then I must have two oxygens on this side. As a net result of this, I'm going to end up with two calciums and two oxygens, thus having to change this use of coefficient. Now I have two calciums, two oxygens, two calciums, two oxygens, showing the conservation of matter and mass within the chemical expression. Looking at example number two. Example number two, we are going to have sodium, which is Na, plus our chlorine, which we know is diatomic, producing or yielding NaCl. Again, doing the tally system, I have Na and I have Cl on both sides, Na and Cl. On the left-hand side, my reactant side, I have two chlorines and one sodium. I have one sodium and one chlorine. To balance this, same as I did with the last one, put a coefficient of 2 out in front. Now I have two chlorines and two sodiums. So the only fix that I need to do is add a coefficient of 2 out in front of my sodium, and now I have the conservation of matter. I have two sodiums, two chlorines, two chlorines. In example number 3, we're going to get a little bit more difficult. What I have here is iron 2 chloride. Adding that to our sodium phosphate here. Okay, so Na3PO4. Producing or yielding our sodium chloride plus, looks like we have iron 2 phosphate. We're going to have 3 of those and 2 of those. Okay, so looking at this example, we have to balance, again, the reactant side with the product side. So on the left-hand side of our equation, we have one iron, we have two chlorines, we have 3 sodiums, and we have one phosphate group. In this case, you can keep your polyatomic ion together since it is present on both sides. So actually, to keep these consistent here, iron, I have 3 of. Chlorine, I have 1 of. Sodium, I have 1 of. And my phosphate, my PO4 here, I have 2 of. So you have to look at the following in order to figure out some changes. So the one thing that I like to look at is the larger aspects. So I have 3 in here, and I only have 1 over here. So by changing this, since my chlorine is a multiple of 2, I know that's going to stay an equal number. I like to try to deal with equal numbers here. So I'm going to change my irons over here, and I'm going to put a coefficient of 3 out in front. Now that I put a coefficient of 3 out in front, now I have 3 irons, but I have 6 chlorines. Well, one of the problems that we're going to run into is now I need to fix that on this side. So now that I put 6 chlorines, now I have 6 chlorines. But I'm also going to have 6 sodiums. Easy way to fix that, now that I have an imbalance between these, is now this is 3. If I put a multiple of 2, 2 times 3 is now 6. 2 times 1 is now 2. Check our answer. 3 iron, 6 chlorine, 6 chlorine, 6 sodium, 6 sodium, 2 phosphates, 2 phosphates. And your expression is now balanced.